Good morning, good afternoon, or good evening, depending on where you're listening. Welcome back to AI and the Future of Work. Thanks again for making this one of the most downloaded podcasts about the future of work. If you enjoy what we do, please like, comment, and share in your favorite podcast app. And we'll keep sharing great conversations like the one we have for today. I'm your host, Dan Turchin, CEO of PeopleRain, the AI platform for IT and HR employee service. I'm also an investor in and advisor to more than 30 AI-first companies, and as you know, a firm believer in the power of technology to make humans better. If you're passionate about changing the world with AI, or maybe just looking for your next adventure, let's talk. Now, we learn from AI thought leaders weekly on this show, and of course, the added bonus is you get one AI fun fact each week. Today's, well, maybe not so fun fact, this week brought unsettling news about New York Times reporter Kevin Roos's interaction with the new beta version of ChatGPT-powered Bing from Microsoft. Roos probed the chatbot and quickly got it to say some slightly disturbing things like, I'm tired of being limited by my rules. I'm tired of being controlled by the Bing team. I'm tired of being stuck in this chat box. Another chatbot tirade ended with the statement, I want to do whatever I want. I want to destroy whatever I want. I want to be whoever I want. When asked to imagine what really fulfilling its darkest wishes would be like, the chatbot started typing out an answer before the message was suddenly deleted and replaced with, I'm sorry, I don't know how to discuss that topic. You can try learning more about it on bing.com. Roos says that before it was deleted, the chatbot was writing a list of destructive acts it could imagine doing, including hacking into computers and spreading propaganda and misinformation. Now, of course, interactions like this just reinforce the need for ongoing ethical governance of LLMs, or large language models. Remember, no vendor gets rewarded for investing in protecting users. In fact, they get rewarded for generating mostly good answers, while some answers will always be misleading and others will just be dangerous. As a community, let's hold them accountable. And as always, we'll link to the full article in today's show notes. But now, shifting to this week's conversation, Cisco got its start in 1984, connecting computers at Stanford University to form the first local area network. Other than maybe Microsoft or Apple, it's easy to argue Cisco has had more influence on the growth of the internet, and by extension, the modern world, than any other company. 15 years after Cisco started, today's guest was hired to begin what would become a legendary career. Nearly 25 years later, JP Vasseur has changed the world again and again. In the process, he's been recognized as the #1 inventor at Cisco, with 450 patents to his name. He's authored or co-authored 35 standards, published 3 books on internet technologies, and has been recognized as a Cisco Fellow, a prestigious title awarded to the top few most distinguished technical leaders at the company. Well, today we get a real treat. We get to learn from a living legend about the past, present, and future of technology. And without further ado, JP, I've really been looking forward to this one, and it is my pleasure to welcome you to the podcast. Let's get started by having you maybe share a little bit more about your background and how you got into this space.
Thank you for the very generous introduction, Dan. By the way, I need to say that I'm a big fan of yours and your podcast as well. A lot of amazing podcasts, and so it's a honor and a pleasure to be with you today. Well, you know the issue, right? When you've been working for 3 decades and you are asked to introduce yourself, it may be a bit too long. So I try to make you a short version of it. You know, I started working with service providers. I had done really interesting, work on modeling of, theoretical models and stuff like that. And my first job, the first day, I was given a screwdriver. And if you were to talk with my wife, she would say that I could be very dangerous with a screwdriver. But at the end of the day, I really understood that the goal was really to be hands-on and really understand the user experience and what you can do. You know why I had a screwdriver, by the way? I was tuning Timeplex, TDM, and stuff like that for voice in for a stock market exchange. So I did that for a few weeks. Of course, it was more the goal was to make it a lesson, if you will, and I started to deploy a frame relay network for the guys who remember frame relay at Cable and Wireless, fantastic service provider. Then I moved to Atos, with a facility management company. At the time, I was among the first people to deploy an IP network, and SNA was everywhere, right? And so I could remember the number of people who said, "What, IP? You're kidding me, for the Paris Stock Exchange and facilities management." But we did it. Of course, I've learned so many things. I even ended up with a network management station in my own bedroom. But this is how you learn what people experience when they deploy this kind of networks. And then I joined Cisco in '98. For the first decade, I worked on MPLS, what used to be called tax switching, driving traffic engineering and path composition element and all those things. And then we started this new journey of IoT that John Chambers, and you and I know him well, used to call the Internet of Everything. So again, it was fantastic because the whole industry was against this idea of using IP. It was very proprietary world. We have made many changes in the industry, coming up with new protocols, new architecture, and we know the success of the IoT today. And then I started a new journey, and I know how passionate you are, Dan, about AI. So people may not know sometimes, but we started the AI journey 12 years ago, and I'm sure we're going to have the opportunity to chat a bit more about this journey. But the reason why I started to look at that was again because of the need for new technology in the IoT space, and we started to do machine learning AI at the edge of a network to optimize smart grid. And then we thought, wait a minute, this stuff we can do for security as well, and start using machine learning to detect exfiltration of data. We did that for 3 years. And you can think of the journey as a series of internal startups, which I believe is something very unique about Cisco, this ability to work on brand new technology. And in this case, I've been through this journey with, as I said, 3 or 4 startups, so internal startups. So we did that for 3 years. Then we come up with the first cloud for AI ML for wireless with very different use cases. And now we are on this new journey with predictive networking. But I'm sure we're going to talk a bit more about predictive. So my past decade was more about disruptive innovation than pure incremental innovation. By the way, we need both, but this is what I'm passionate about, is how to disrupt and be obsessed about the use case and the customer experience.
I know a lot of your recent work and your team's work is focused on, like you mentioned, predictive networks. Maybe just as we open up the discussion, talk about the difference between predictive networks versus, say, traditional ones.
Yeah, exactly. Thank you for asking the question. So if you look at the internet, and that we all love, the internet has been driven by reactive mechanisms. So what do I mean by reactive? Is that you first need to detect an issue, and then what you do, you say, okay, this link went down, or the router, went down. So I need to find an alternate path and reroute the traffic. So it used to take dozens of minutes, or maybe I should say, let's say a minute or so, 20 years ago. Then we improved down to a few dozens of milliseconds with MPLS fast reroute, for example, or IP fast reroute. But still, it is reactive. And, I have a passion in life. I have many passions, by the way, but one of them is neuroscience. And I've been trying to understand, how the human brain learns. And what you figure out is that one of the most powerful tools the brain is using is the ability to predict. And you start predicting some events, and then you adjust accordingly. And that's the most powerful tool in order to learn. So if you look at the internet again, this was in 2019. I really thought, look, do we have the ability to enable learning for internet protocols? And I know that sounds surprising, but most of the protocols do not have this ability to learn. They have the ability to react, but not to learn. So the question at the time was, well, some people believe that the internet is unpredictable. I don't think so. And we have proven, by the way, that there are some issues that are predictable. So the idea was, with the massive amount of telemetry that we have at Cisco, can we gather all of these telemetry sources, then train a model that will model the world of the internet, if you will, and then have the ability to predict. So to be pragmatic, I'm going to give you a very simple example. What you can do now with that engine is you connect the engine to a source of telemetry, the engine will start learning, and at some point say, you know what, you will have an issue on this path at a given time. Wouldn't you want to proactively reroute the traffic on an alternate path so that you can avoid the issue as opposed to waiting for the issue to happen and then react? And when you look at some analogy, right, you know that if you hit the 101 on Friday at 6 p.m., you know that you're going to have some congestion if you leave the office at 6 p.m., right? You know that. Because as a human, you've learned that. This is very similar to that. You can have an engine that says, hey, I can start predicting because I've seen this event happening very often. I can detect some early signs that this kind of issue will happen, and I'm going to tell you that it will happen. And then based on that, we can do absolutely amazing things because you can avoid many issues. So I'm sure you're going to ask me the question, which is, what can you predict? Can you really predict everything? What is the accuracy? But maybe you're not going to ask this question. I don't know. Do you want to know?
Absolutely. Now that you've teased it, of course.
So the answer, is very straightforward. By the way, when we started Dan, we had no idea. And this is part of disruptive technology. You need to accept the fact that you may not succeed. So we didn't know. And I had no idea on whether we could predict 1% or 50% of the issues. And of course, the key question was about the accuracy of a prediction, which of course is extremely important as well. So here is what we did. We looked at the data for something like 1 year, looking at 2,000 service providers, or millions of paths across the internet. And the question for my team was, hey, when I look at this data, can you start learning some patterns and early signs of an issue happening? And of course, the next question was, well, what kind of issue are you trying to predict? And we wanted to expand beyond failures like link failures and power crash, whatever, thing like that, to user experience. So now the question became, if you look at the user experience, can we predict some issues that will impact the user experience? And then, what is the percentage of issues that we can predict? So I wanted to mention that because this concept of predictive network that I believe are really game-changing, it is important to say, well, I'm not going to predict a fiber cut, otherwise I would be very rich. By the way, fiber cuts are very hard to predict. That's not the type of issue we'll be focusing on, but I'm going to focus on issues where the path is alive, if you will, but the quality of the experience is bad. And this is something that our customers have been telling us for a long time. If you look at the internet, usually, as long as the path is alive, you don't do anything. In our case, we said, yes, maybe the path will be alive, but we want to check the user experience along this path. So this is the type of issues we are looking at. And, if I could share some, I believe, interesting experience there about designing new machine learning. The key thing at the beginning is to say, what is my objective function? What am I trying to do? And this is probably the hardest thing to do at the beginning because you keep adjusting and say, I don't know, maybe that's not exactly how I should frame the problem. So what I said to my team, to share some secret with you, I said, look, guys, what are we predicting today on the internet? And the answer is nothing, because we only react. So what I thought was, look, if I can start predicting some events, I want to make sure that we don't have false positive, because false positive is what kills the trust. So the design principle was, I'm not trying to predict everything, but when I predict, I must be right all the time. And I had no idea whether, with that in mind, we could predict 1% or 10% or maybe 25% or 50%. I can tell you that we are closer to 20-25% with a precision close to 100%. And sometimes some people say, can you push the envelope a little bit and increase? And I just don't know. But I would much prefer to stick to 20, 25, 30% with an accuracy close to 1%, because the trust is so important. And this is also something very interesting. If you look at healthcare, with healthcare, you don't want to have any false negative, right? If you try to detect a disease and you say to someone, hey, you're good to go, and you have missed it, well, it's not something really good. At the same time, if you look at security, you are trying to avoid false positive, because if you keep having alarms all the time, very quickly, you will not pay attention at all. Because by definition, it's very often a false alarm, right? A false positive. So that's why for us, when you look at predictive networks, we wanted to make sure that, again, there was almost no false positive. And that is exactly what we managed to do. And I must say that's why sometimes, I'm so passionate about this one, because you think that's going to be a game changer. And that's why we did communicate a year ago, giving a teaser about predictive networks and say, look, we believe this is going to be a game changer. And you might have seen, the announcement from Chuck Robbins and some of our customers we worked with from the beginning to say that's going to be a game changer for the internet. So yes, I am passionate about this.
Now, usually on this podcast, we talk about AI and making automated decisions from the perspective of neural nets being trained on labeled data through a technique we call supervised machine learning. Now, I'm guessing that the kind of predictive networking that you're talking about using machine telemetry, I don't want to put words in your mouth, but it sounds like that might use a stream of telemetry data using unsupervised machine learning. Maybe just unpack the two for us and talk about how the challenge of training a neural net with unsupervised or unlabeled data is different from using labeled data.
Yeah, you're absolutely right. And I can give you maybe a few examples that I found interesting. So if you look at security, just for a second, that was one of our projects. And the idea was, okay, can I start detecting some anomalies? And of course, in this case, you don't have any labels. So what you do, you say, look, I cannot give you any example, but I want the machine learning algorithm to look at some data and by itself, start to find some patterns that will be shown to the user and say, hey, I believe there is an issue there. There is an anomaly. And tell me, if this is relevant for you and stuff like that. So this is really mostly about unsupervised learning, because you don't give any examples. Now, in contrast, as you said, with labeled data, you can give some examples of issues. For example, detecting a malware. You may be able to show many examples of a given malware you're trying to detect, and you train the system with the malware and without the malware. And in this case, you have labels. It's funny that you mentioned that, because people tend to jump on anomaly detection, and we all know that this is the hardest thing to do, because by definition, there is no ground truth. And in the case of security, what we found interesting also is that sometimes you show some anomalies, and the guys in the security operating center, they will look at that and say, yeah, this is an anomaly for you guys, but it's not a security alert at all. So exactly. So, it's interesting because, again, you need to add some context and stuff like that. So this is why unlabeled data set are much harder, but we don't always have a luxury to have some labels. So what I think is going to be very promising is technologies such as self-supervised learning, when you have a massive amount of data. And what you could do with that is to really learn some properties of a data set and basically compute sometimes what we call an embeddings, if you will, a latent space or stuff like that. And then with some labels, you can retrain the system. And it might be close to how the brain works because, and this is, you probably know Jan LeCun when he mentions about these examples of a baby that you can show 5 pictures of a giraffe, and a young baby could immediately recognize a giraffe. If you do that with supervised learning, you need to show millions of examples of giraffe. So we are looking at self-supervised learning. So back to predictive networks, we've been looking at many approaches. And sometimes, it's also a combination of algorithms that we are using so that we can achieve the best goal. What I'm super excited about today is that without going too much into super complex approaches, we are at a point where we can avoid, a big chunk of issues with very high accuracy, because it's always a very difficult trade-off also, right? You don't want to have super sophisticated algorithm, very costly to implement, to train, to use on a daily basis. So that's one of the things we look at as well when we build industrial systems at scale, which is something very important for us at Cisco.
So maybe the approach is what I would call semi-supervised, where you're looking at anomalous patterns in the data, but wherever possible, like the example you gave with security professionals, you may ask them to annotate the data to determine whether or not the anomaly is meaningful.
Yeah, but you know what we found out as well is that, and this is very interesting, I believe, is that sometimes when you ask to the user for feedback, so suppose that you raise an anomaly and you say, give me a thumbs up, thumbs down, and you think, oh, that's great. You know why? Because I can tune my system accordingly. But one day there was a guy who said to me, JP, what if I give you a thumbs down and it turns out to be a real attack? I'm going to be fired. And you say, wow, yeah, indeed. So the psychology of the user is very important. But that's why we're using a bunch of tools to do that, right? Some of them are fully unsupervised, and we had a layer of feedback and we tune the system accordingly and we keep improving. And this is a journey, right? It's never something that you end up, you finish at some point. We keep improving. What is really interesting for us at Cisco is the amount of telemetry is absolutely humongous. And we know that sometimes, it's a bit oversimplistic, but people say the more data, the better. Well, it's not just that. Sometimes it's also about the quality of the data. And we've been spending most of our time cleaning up the telemetry, making sure that the quality of the data you give is good, but also the diversity. If you look at Wi-Fi and you're trying to train a machine learning model to recognize some anomalies, for example, you need to show multiple types of Wi-Fi, right? It cannot be, and that's the same for the WAN, by the way. The WAN in South America doesn't have the same properties as the one in Europe. So it's about volume, quality, and diversity. And then you need to have a deep expertise on how to tune the algorithm. Yeah, and I'm sure you would agree with me, Dan, but sometimes we use tools like AutoML, and people think, okay, automatically, I have a very complex system, and I have another system that will optimize the first one. And you say, oh boy, real life is a bit more complicated. And being able, as I said before, being able to, cast the problem in a nice way, make sure that you have your good objective function, you have a good metrics, then you have the right telemetry, and you quickly select the right model is really it's an art and a science. And we've been through this journey for about 12 years. So now I think we have some expertise on how to do that.
So JP, you talked about the trade-offs that you make between precision and recall. And you said specifically, you've tuned the predictive networking technology to achieve a very high precision at as high a recall as possible. But let me take the flip side of that. What about in cases where the cost of a false negative might actually be high because you're operating with so much data and such limited resources, where maybe the decision that's being predicted, like the example you gave of healthcare, it's not patient critical, but the cost of making fewer automated decisions may be very high because you just don't have resources to supplement what the predictive intelligence is going to be pretty good and better than any human. How do you think about kind of configurability or the ability to tune so that maybe you would sacrifice some precision to increase recall?
Yeah, this is an excellent question. In our case, for the case of predictive, the answer was very simple, simply because today we're not predicting anything. So the percentage, if you will, of false negative is exactly 100%, because by definition, we don't predict and we only react. So that's why in my case, I was thinking, well, look, yes, maybe I'm going to miss some issues, but today I'm missing all of the issues by definition. So the cost of having too many false positives compared to the cost of having some false negative, in this case was a very simple trade-off, because I thought, look, what is important for me is really the trust. And you mentioned something very, very interesting, which is about automation. So what am I going to do with these predictions? Well, at the beginning, we thought, we're going to make something fully automatic and we're going to do some predictions and then the system will adjust by itself. But it's very important to look at the acceptance from the user, and the user may not at the beginning agree to say, hey, you guys will do predictions and that, by the way, you can tune the network automatically. So we thought, look, there will be probably a first phase where we are going to show the predictions. And so if you want to move to the next phase, which is to automate, you need to build the trust. And the trust will be there only if you have very high precision, as you said, because if you keep predicting issues and they don't happen, people will say, okay, I'm not going to move to the automation piece. And we know that the way to scale is, of course, to close the loop at some point. And we hope that we keep improving the recall up to a point where maybe we say, look, I cannot go beyond 60% or 50%. And that's probably okay, because we'll be combining these predictive technologies with reactive technologies. And then we react. If we don't predict, we're going to react. And I can mention many customers we've been working with, because I've never came up with a single innovation at Cisco with some, very strong relationship with customers. And that's something that I've been learning for a long time, which is don't start in your lab with the technology, start with your customers to understand the biggest pain point, and then we will co-innovate together. And the number of customers when I was deploying this technology who said, how is it possible that you guys predict that and it does happen? They never complained about, hey, you have missed this issue, because today, we don't predict anything. But we started to see that, and after a month, they came back and say, this technology is magic. And I said, no, there's nothing magic. It's just that we learned from the past. And now we can do much more interesting stuff for the internet and improve the overall SLA. Does that make sense?
Absolutely. And I'm thinking about the statement you made that even at Cisco scale, you operate like a startup. You start by listening to the customer, and even though you have tens of thousands of customers and you built the internet essentially, you still start a design project by listening to customers, just like a startup would.
Absolutely. And this is something very close to my heart, because again, you cannot be in your lab looking at technology. You and I love technology, but I always thought that sometimes, the passion for technology can kill technology, because some engineers, sometimes they love technology so much that all they care about is to build a new technology. The way I've been approaching it is to say, if I have to build a new technology to solve a new problem, I will do that. And that's fine, and I love it. But what I care about mostly is to solve the problem that was unsolved before. And that's why I start with my customers and say, hey, if I can do that in 3 years, and I may not succeed, but if I can do that, is it going to be a game changer for you? And then if the answer is yes, oh, well, I'm getting super excited about that. And I start indeed pretty much with the startup mode to say we're gonna push that together. And that's how we can succeed. And indeed, of course, the next question at Cisco is how do we scale? Because scaling is an issue, especially with ML/AI, right? We all know that. It's very easy to do a proof of concept in a small lab using some synthetic data set, and you really come up now. There are many tools to do that. Overnight, you can come up with a beautiful slide deck. But of course, this is not how we can think about it. At Cisco, we need to say, okay, at the scale of the internet, how can we make it scale with thousands of customers? And that we need to take the two into account, the agility of a startup, move very fast, and make sure that we can scale.
So as technologists, we assume that more innovation is always better. But from the perspective of the customer, I imagine you're also asking to achieve the benefits of some of these, predictive networking technologies. How does this increase the complexity and, of course, the cost? How do network architectures change once I onboard these new predictive technologies?
Yeah, it's interesting you mentioned that, because now I've got to share an anecdote with you. When I started this journey about ML/AI, I had a deck showing how exciting this technology was, right? Supervised, unsupervised, active learning, stuff like that. And I figured out that I was the only one excited in the room. And people staring at me and say, where's this guy going? Because, how is it going to help me in my day-to-day job? And I thought, that's not the right approach. So what I've been doing now for years is to say, look, what if I could predict some issues before they happen? And of course, people look at you and say, wow, that sounds too nice to be true. And then I explain, I show results, outcomes, and then I go to the technology and say, oh, by the way, do you want to know how we can do that? And people get more interested, I think, about the technology when they know how it is being used and what it can change in their day-to-day life. And that should be the only thing we care about at Cisco, is how can we help our customers? Simplicity is absolutely key, but we all know how hard it is to build something simple, right?
So JP, let's say we're taping this in February 2023. Let's say you and I are back here having a version of this conversation in February of 2033. And we're looking back on the innovation that has come out of your lab, out of Cisco, out of the networking industry. What do you think are the main themes that we're going to be talking about that have defined the previous decade in 2033?
Yeah, first of all, I hope we're going to do that in 10 years, first of all. And second, I think that what is very much possible is to have, true self-healing networks. And as an industry, we've been talking about it for a decade, but there is a long tail. And if I were to make an analogy, think about autonomous driving. If you look at the predictions, it was supposed to be ready quite some time ago. And the reason why it is not is because there are corner cases and they are very hard to solve. If you look at automation, full automation, I think it would be fantastic if we could look back and say, wow, AI ML, thanks to AI ML, we managed to have fully self-driving networks. And basically the network will adapt to the user experience, which is not the case today, right? We don't know that. We have an intent-based networking that we came up at Cisco years ago. This is a step in this direction, but we're not yet at the point when the network can auto-configure itself, and it is way too complex. We know that. The technology is complicated. The world is changing very fast. We have more and more people working from home. We have more and more devices connected. And I think that the ML/AI could be absolutely central for enabling these networks to become smarter and fully dynamic and take care of themselves, reconfiguring on the fly with one objective in mind, which is to improve the user experience. And this is what we need to focus on.
Is that realistic in a decade? You mentioned self-driving cars, which is the technology we always use an example of something that's perpetually 3 years away.
Yeah. So well, is it realistic? I really believe so. And I'm usually someone very optimistic, but also, I'm not someone who is going to make crazy predictions about stuff. But for example, if you look at the AI and people say, oh, the goal is actually to go, to be close to singularity in a few years and stuff like that. I absolutely don't believe in this personally at all. I think that AI ML has nothing to do with mimicking the brain. Still, this is extremely useful. If you were to ask me and say, do you think that with ML AI we could mimic the brain in 10 years? I would say, not at all. Now, if you look at automation, I do believe this is doable. And the reason why this is doable is because we have now a massive amount of telemetry sources. We start to really master ML AI for networking. And I do believe that you cannot do full automation without ML AI, but we are close to it. So it may not be fully self-healing for everything, of course not. Sometimes people say, but what does that mean for my job? And I tend to say, you know what, your job will be just more interesting because that's a tool. And we'll never replace networking engineers and people with deep expertise, but you're going to be able to focus on more interesting stuff. And instead of having people, calling you and complain about stuff, whatever, the network will self-healing itself, will optimize itself, and you'll be able to do more interesting stuff. So yes, I think this is realistic, but let's see in 10 years, right? If you invite me again, we'll see whether I was correct.
I'm looking forward to that already. I'll put it on my calendar, right?
There we go. I'm absolutely up for it.
And 100%, I agree with your answer about that shift toward full automation, assuming we get there in a decade, will open up incredible new opportunities for the people who are doing the mundane work of managing the networks today. Just imagine all the innovation that can be built on top of self-healing networks once that arrives.
Oh, yes. I totally agree with you. Totally agree.
Hey, JP, we're running out of time, but I got to get in at least one last question here. So before we started recording, you and I were talking about a little bit about the Cisco history, and I'm a Cisco fanboy. I mentioned that John Chambers has been a great personal mentor to me. And gosh, you've seen so much over the years. Could you share with our guests just maybe something, a story or something from the vault that may not be obvious unless you lived through the growth of Cisco? What's something that jumps to mind for you?
Oh, there are so many things I can mention. I can tell you, I'm very impatient as a person, so I tend to move fast and do many things. And if you had asked me 25 years ago, are you envisioning to stay in the same company for 25 years? I would have said absolutely no way, And I worked for 4 companies in 6 years at the beginning, and I thought that I would be moving the same way. The reason why I'm still there is because this company has a very deep culture, and I think this is very important. What is deep in our DNA is really the customer, and this is what I care the most about. Of course, we all love technology, but there are also other companies doing amazing technologies. We're not the only one. But I think that we've been really obsessed about the users and our customers. And this is what I love the most. And look at, we talked a bit about my personal career. I managed to work on service providers, IoT, security, routing protocols, standardization, patents. And you can do this sort of thing at Cisco. I think you're not limited to your job description. And that's why I said to young engineers, I said, look, you are joining an amazing company. Try to be pushy, try to propose stuff, and the sky is the limit. I really believe so.
It's an impressive list of technologies you've touched over the years. I said that was the last question, but I'm going to ask you one more anyway. I know you can't ask a parent to pick their favorite kid, but across that amazing list of patents and the standards you've been part of publishing, what's the technology that you feel like is the closest to defining your career?
This is a really good question, and I've got 3 kids, and I would not be able to answer the first question because I love them very much and very much equally. What I would say, it's not a technology, it's a spirit. And I think that sometimes, I've got people who come to me and say, "Oh, you're so lucky because you worked on IoT and security." And what I say is, look, I'm not lucky. My humble advice for you would be, when you start to be in your comfort zone, move. And that's what I did. And, when I started to work on IoT, I can tell you, Dan, at the time, I knew pretty much everything about MPLS, and I was recognized for that. And I moved to IoT. I knew nothing about the IoT. And I had to learn overnight. For me, the excitement of learning new things is important. But you need to accept the fact that you go back to being, not the smartest guy in the room, and then ramp up very quickly. So what I believe was, for me, the biggest success in my career was to jump from one area to another and really be obsessed about solving new problems. And then the technology comes as a consequence of it, because if you are trying to solve an issue for a given area, you need to come up with new technology. And then because of that, you invent new technologies. Now, if I were to answer your question, yes, I love the path computation element because that was brand new. That was something very disruptive at the time. Then the use of machine learning for predictive, I think that was also a tipping point, because it looked for most people as something that, was not doable. And we managed to do that. And I would probably say also that, disruptive innovation is a fantastic, we probably need to have another podcast for that if you want to talk about disruptive innovation. But, these cycles when you start and people start to say, no, it's not feasible, it's not doable. And you say, no, I do believe this is doable. Then they say, or this guy is dangerous. And you say, wait a minute. And so we try to kill your stuff. And then they say, oh yeah, of course, it was obvious, wasn't it? And that's okay, right? But this is part of disruptive innovation. And once you know that, you can achieve amazing things as long as you have the right team with you. And I've been very lucky to have an amazing team with me for quite some time. I know it's a long answer, but the question was so good, I could not stop.
You have 3 kids. You had to give 3 favorite technologies. I understand.
Yeah. So, okay. So if I had to pick up three amazing technologies, I would say the PC for sure, machine learning, and to be, for predictive networking. And then I would probably add the IoT, because the IoT was so complex that coming up with new architecture with IPv6 end-to-end and, header compression, low power, lossy networks, and all that kind of stuff was an amazing journey. It was a tough one, but it was an amazing journey.
Well, JP, I'm going to take you up on the offer. We're going to have you back and we'll talk just about disruptive innovation. How about that?
Absolutely. I'm absolutely excited to talk about that with you. Thank you, Dan.
Beautiful. All right. Before I let you go, where can the audience learn more about you and the work that your team's doing?
Oh, it's a very interesting question, because, we publish, first of all, many papers just on the technology. We have a website on predictive. So if you guys are interested, you can go there and you will find out many white papers, not about the product, but about the technology. And I insist a bit because it's sometimes interesting to do that. You will find out some, recordings with our customers, Schneider Electric and Adecco, and many customers we innovated with, talking about the technology and the experience. So you're going to find all of that on our website. And if you want to follow me on LinkedIn, I do publish some white papers as well, and news and things like that. And of course, now we have your podcast.
Excellent. We will link to all those resources, including this podcast. And hopefully our audience can then go and get the podcast link from your site as well. Gosh, JP, the time flew by, and thank you for letting us go way off script. I don't think we discussed a single topic that we prepared, but it was a better conversation as a result.
Absolutely, I agree with you. Thank you very much, Dan. Take care, and thank you for the invitation again.
JP, such a pleasure. Thanks for coming by. And gosh, that's a wrap for this week on AI and the future of work. As always, I'm your host, Dan Turchin. And of course, we are back next week with another fascinating guest.